Okay, so in this video, we're going to be looking at vectors again, looking at more questions that could come in your A-level exam, or it could come in your AS mock. We are looking at vectors in mechanics that we are covering, and this content is for OCR, Edexcel, AQA, and international A-levels. Okay, so that's what we're looking at now. Just before we start, just to remind you, please click the subscribe button at the bottom if you're watching us from YouTube. And also please share these particular videos with your friends and family so then they can also get to learn with us. If you're looking for tutoring, the number to call is this one. This is 0742 if you're within the UK. If you're outside the UK, then this is the number you can call. Alternatively, you can just send us an email. You can just send us an email and we will get back to you. Okay. All right, so this is it. So we start now. Now, if you've not watched my first video on vectors, video 1 and video 2, I would like you to go watch them because I've gone through the basics of vectors for year 12 and year 13. But if you're happy and you want to try this question first, I would like you to try it. So pause the video and have a go at this question. Pause the video right now. All right, so I hope that you've tried it. Now I want to go over it. If you haven't gone over it, please pause the video and do it. Otherwise, I'm going to run through it right now. Okay, so I'm going to start right now. So it says at time 2 p.m., the position vector of ship P is this, and the vector of the other ship is that one. So I can draw just the XY axis to give you the perspective where these things are. So the first one is 5 across and 3 down. So it's 5 across on the X and 3 down. So kind of here, this is 5 and this is 3 down. So this is where the first one is, which is P. Okay. And the position vector of ship Q is 7 and 5. So it's 7 across, which is kind of there, and 5 up, which is going to be here. That's 5. So this is where Q is position-wise. All right. So if I just take these numbers out, we now know where they are. That roughly that is where P is and where Q is. Now they say find the distance between P and Q. Now to work out the distance is basically from P to Q. That's the distance they're talking about. But in terms of the movement from P to Q, I will move across like this, and then I will move up. All right. So I'm ending up with a rectangle and a triangle there, and I can do Pythagoras like this. So movement at the x-axis will be the difference between 5 and 7. So that's going to be 2 across. Okay. And then movement within the y-axis is going to be -3 all the way to 5, which is going to be 8. So it's 2 across and 8 up. And all we can do is just do Pythagoras for that, and that's going to give us the distance. So it's going to be 2 squared plus 8 squared, and then you just square it. That will be that. Okay, so let's repeat this. If you're finding displacement vector from P to Q, okay, this is what you need to do. You're going to need to do the position vector of Q, take away the position vector of P. Are we there? So Q is 7, 5. So that's 7 cross and 5 up. So 7 on the I and 5 on the J. Subtract them. P is this one. So P is 5 across and -3 down. Subtract them. 7 take away 5 is 2. 5 take away -3 is 8. So this is it. That's the displacement vector. But you're looking for the distance. You do the Pythagoras. You do 2 squared plus 8 squared, then square root. That is it. So we are done with that first part. Now the second part says ship P is moving in the constant velocity and ship Q is moving with a constant velocity. So find the position vector of P. Now, position vector at any time of a particle is given by where the particle was at the start times by the displacement V times T. So it says find the position vector of P. So if you're looking for where P is at any time, the R naught for P is where P was at the start. And P was 5 and -3. So it's 5, -3. Okay. And then time that it took. We've been told that find the position vector of P at time T, hours after 2 p.m. So we don't know what T is. We just know that it is T. But the velocity we've been given is 2 plus 5 is 2 plus 5 like that. So if you tidy this up, it's going to be 2t plus 5. It's going to be 2t plus 5. And it's going to be 5t, 5 times t minus 3. So it's going to be 5t minus 3. So this is where it is at any time. At any time. Position vector. So we are done with that. Now, find the position vector of Q. Position vector of Q is the same approach now. So we're going to do R of Q. That's going to be the R naught plus the displacement. R naught is where it was at the start, which is for Q is 7, 5. That is 7, 5. The displacement is time times by the velocity, which is 7 plus 5. No, which is minus 3 minus 15. So minus 3 minus 15. That's it. Let's simplify this. T times minus 3 is minus 3t plus 7 at the top. Okay. And then we also have negative 15 times t plus 5. This is it. These are the vectors now where they are at any time. So this is RQ, and the bottom one is R naught. RQ and RP, sorry. So RQ and RP. The bottom one, this one, this is RP. This was RQ. All right, so we have that. That's where they are at any time. So if you tell me the time, I just sub it where t is, and then I can work out exactly where they are. But this is it. Okay, this is it. All right, now let's move. It says find the position vector of Q at time t hours after 2. Found that. D, show that Q will meet P and find the time at which they meet. Now, if they're moving at some point, so let's say that P is moving like that, and Q is moving like that. At some point, they're going to be in the same position. So this is, maybe this is Q and this is P. This place, their I component will be equal. Their J component will be equal as well. You see this? Because they're in the same position. So show that Q will meet P and find the time at which this is going to meet. So if they're going to meet, it means that their I component will be equal. So which means that I can make this one equal to this. Sorry about that. This has just popped up. The answer. Okay. So I'm just going to use the answers that have just popped up by accident. So the component, the 2t plus 5, which is this one, should be equal to minus 3t plus 7, which is this one here. And that will give us t to be 2 over 5. I think that's 2 over 5. Done. We can also equate the I components, the J components. So minus 15t plus 5 equals 12t minus 3. And that's what they've done here. And that's giving us the same answer, 2 over 5, which means that when after t equals 2 over 5 of an hour, they are meeting. All right. So I think this is 2 over 5. I'm not seeing it clearly, but it's 2 over 5. So after the journey began, they will meet after 2/5 of an hour. So I've got P. It says, show that Q will meet. Now, if they were not going to meet, I wouldn't have been able to work out T. I wouldn't have been able to work out T. And the T I would have got would have been different for I and J. See? Now, find the position vectors of the region at which they meet. This is easy. Once you know what T is, which is 2 over 5, you plug it into any of them. You can plug it into the RQ here and find that, or you can plug it in there and that will show you where it is. All right. So that is how to do that question. That's how to do it. Okay. Yes, I hope that you're happy with that one. Now we're going to move on to the next thing. And the next thing is going to be the next question. And that's going to be this. All right. So pause the video and have a go at this one quickly. Pause the video and have a go at this one. Okay, so I hope that you've tried that. Now let's go over it. Now, I told you in previous videos, when you're looking for the direction of motion, the direction of motion is given by the velocity vector. And if it's a constant velocity like this, it's very easy now. So you pretend that that's the starting point. For every 6 that this thing moves back, because it's negative 6, it moves 2 up like that. So this is 6 and this is 2. That is the direction that this thing is traveling at. You need to work out this angle, and then to find the bearing, you know bearing start from the north and it moves clockwise. So you do that, you do 90, 90, 90, 90, that's 270, and then you just add that. That's how to do it. So I've done this in my previous videos. You know that the opposite is 2. I just said it's 6. You use tan. So use tan to find that angle. Once you found that angle, you now add 270 because bearing is measured from 0, 0 clockwise. That's how to do that part. For part B, write down the position vector of P. The position vector of a particle at any time is given by where it was at the start plus the displacement, which is v times t. If this is constant, that is how to do it. Okay. So initially it passes through the point with your vector this. So initially it was at 21i and 5j. And the time, they just say time. They didn't tell us the time. So I'm going to have t, and I'm going to times that by the velocity vector, which is minus 6 and 2. So this is it. So I do t times minus 6 plus 21. That's going to be minus 6t plus 21. Done. Then 2 times t plus 5. That's going to be 2t plus 5. Done. This is the velocity vector that this thing is having. So if I know t, I can work out. No, this is the displacement, the position vector, r. So if I know what t is, I can tell you where this thing is. Okay. Now, find the time at which p is northwest of O. Now listen. If it is northwest of O, north is here, right? And then west is here. So northwest is going to be like this. This is northwest. Now, for it to be northwest, that means that this has to be 45. Okay. And if it is here, that would imply, therefore, that the displacement along the x should be equal to the displacement along the y. Because this triangle here is what? Is isosceles. So for this to be 45, that means that is 45 as well. So that means that the displacement along the x should be equal to displacement along the y. That's just what it is. So wherever is in terms of x and whatever is in terms of j should be equal. You need to make them equal. So you're going to be making this one. You see this one now here. This should be equal to that one. That's all. The only difference is that one will be negative and one will be positive. So that's the only difference. The length wise, they will be the same. You see this? All right, now, so let's look at it. Now, so position 1. So x is minus 6t plus 21 here. And y is 2t plus 5 here. The only thing that one will be position, one will be negative. So if you're going to equate them, then one of them should be made negative, isn't it? So then they're both the same in sign. Both of them should be the same in sign. And then what we need to do now is just work out what it is. You see this? So we're going to say 2t. We're going to say minus, so x is minus 6t plus 21. This x is negative, right? So we're going to need to make it positive. And then the y is 2t plus 5. This is it. Make them equal and find what t is. That t is the time when they'll be northwest of O. All right. So what I want you to do now before we end this video, I want you to pause this video and try this question again by yourself. Pause this video and try this question again by yourself if you didn't get it right. Okay. Right, so I hope that is how you done that. Now we're going to move on to the next part. First, I show you the answers. And then I move on now. Okay, I move on. Right, so before we stop, please can you click the subscribe button if you're watching us from YouTube and share this video, and remember to like us, please. If you're looking for tutoring, the number to call is this one here if you're within the UK. If you're outside the UK, this is the number that you want to call, or alternatively you can send us an email and we can organize for your tutoring, biology, chemistry, physics, maths, A-level, GCSE 11 plus, give us a ring and we can organize for your tutoring. One-to-one, group tutoring, face-to-face, we do that. Okay, thank you. You can also do one-to-one. As you can see, this is one-to-one. You can click on our button there at the bottom, 11plusgcse.com. Come to our website, get more videos like this, get more past papers, give us a call, and so on.